great to have you here. I know there's a lot of finance people in the audience, so when we say that you're the CIO, you're the Chief Information Officer, not the Chief Investment Officer.
Right.
Got it. I want to start this conversation with a New York City urban legend that was printed in the FT probably a year ago. When it comes to, we're having a conversation about big data, right? And they print this little paragraph. It says, New York City used big data to figure out which drains were getting clogged with grease most frequently in the middle of the night. And then when they figured that out, whoever the grease police are in New York City, I don't know what their title is, they went and hovered around them at night to discover which restaurants were illegally dumping their grease into the drains and causing big problems. And we were all like, wow, that's a really incredible application of big data that we hadn't thought of. Can we use that anecdote to start the conversation about what big data is, why it exists now, and what it can do for us?
We can. It's a true story. But actually, I really like the conversation that's going on here because that's what I'm partial to. So Peter started it off with this idea that big compute capacity is really what's changing the game.
I was going to get there, but go ahead.
and now you've heard it as a sort of a consistent theme in each of the presentations, is we've seen this cost go down on compute, go down on compute. So it's really quite interesting to see that the technology side of the industry, if you will, the IT, is out there beating this big drum around big data when Singularity's got it correct when they're talking about is the change in big compute.
Are you parsing words and the difference between big data and big compute? I think to some people, intuitively, it sounds like it's almost the same thing.
Oh, so the reason I'll say that is I want to classify big data a little bit later. The example of the grease was data they were already collecting. They already had it. It wasn't about having more data, getting more data. It was about combining that data, being able to apply the analysis, to do the learning about what were the relationships, how can I identify the problem. Wasn't possible until the computational costs and the speed made it relevant to the problem.
It got much cheaper, right? Because
Right.
New York City's nearly broke. We're borrowing money like crazy. So if it wasn't affordable, it couldn't be done.
Correct.
Why is it getting cheaper?
Well, we've seen several examples when you talk about the Moore's law as you move out of the transistors into just combination of large-scale grid computing, you get a performance and cost capability that you couldn't touch. And we saw the earlier example of 100 million going down to just what you can carry in your pocket. So the rate of speed, and this is a challenge that we've got right now as I work with customers, is this idea that you can introduce this style of computing, and the model is changing so fast that the current acquisition model for technology is usually a depreciation model 3 to 5 years. The problem is we're introducing new technology and new ways to solve these problems every 6 months. So a lot of our enterprises are broken in their whole process of how they evaluate bringing technology in. This is one of the real challenges here if you're going to make sure you're not left behind by some startup who can do it without any capital expense, go directly into the cloud. You have to have a different thought process about how you actually acquire this technology, how you justify it in the business plan. It has to be on the problem right today, the thing that you can see value today.
Right. So let's break that down. First, let's drill down to the very basic thing of the cost of the computers, and then we'll get to your bigger issue that you're bringing up. You mentioned you just bought 100 servers.
Yep.
What did you pay for them? What did you pay for them 2 months ago?
Let me just say that the price has dropped each of the last 2 months by $1,000 per server. And that I'm now getting 16 cores, 256 gigabytes of memory, 16 terabytes per server. That is a tremendous amount of compute capacity.
And what are you paying for each individual server then?
The supplier would probably not like for me to say exactly what I was paying for the server. So let's just say
but that's a decline of 10%, 2%?
10%.
Rough? Okay. Okay. That's pretty impressive to happen on a monthly basis.
Yes.
All right. So there's one, having the computational power. Then there is, though, you're describing the difficulty. Our IT departments in big institutions are set up in certain ways to answer certain questions, right?
Yes.
and they're not thinking the way that the front of the office thinks? Is that a way to describe it? Can you articulate better what has to happen for the IT department to be able to harness the cheap technology and the already existing data into something that is usable?
I can. It's been one of the things that I've enjoyed through my journey in working with the business units and answering questions is understanding that we've talked a lot. You see it in all the press. You see it in the conversation of IT and the business units not being aligned. And we've gone through a history of, well, we'll get program managers and they'll help us align the activities we're at. Or
Those
we'll
are
get
people who talk to the two different departments.
Yeah,
in
they're
theory,
managing
and
the project.
arbitrators or translators or however you want to,
well,
liaisons.
They were managing, we thought we could manage projects better, and that might have been the disconnect. And then that didn't work so well, and we said, well, we'll get business analysts, and they'll sort of understand our business, and they'll help us go answer questions. So I would submit that maybe there's a different approach, especially for right now, especially in a time where the skills for data scientists are going to be at a premium. We're going to have half of what we need by 2010, if you look at the current projections. So what would happen if all of the people that were working as database administrators or business analysts in IT were trained in the basic principles of forecasting, optimization, and predictive analytics, data mining? Would they be able to approach the business in a different way? Would they understand how you had to organize the data? I just was at an event this past weekend, and GE was there talking about this industrialized internet, the Internet of Things. And one of their big understandings right now is that they have to organize the data for how it's going to be consumed, not by the way it was generated. And we need to get IT to understand that transformation has to occur if we're going to play in the space of big data.
It sounds incredibly difficult intuitively just based on the 2,000 photos that I have on my computer and figuring out which one my dad is in, which one my brother is in. Do I want to search by date? Do I want to search by pixels? Do I want, right? I mean, is this an oversimplified version of what you're trying to say?
Yes. Those apply, though, because it's a set of algorithms that help you do that, right? The facial recognition, you have 6 major points. That becomes the fingerprint of your face.
Right.
What are the algorithms that help you do that? In the area of much of the conversation we've had today, and Jeremy was doing a great job talking about this deep learning that's going on, where you're letting the computational power establish hypothesis and test hypothesis to reduce bias. This is, how do we accelerate our knowledge, if you will, is this great opportunity to leverage computational power to do that. We talked, about this, your core instinct is about a learning, and in that learning process you create bias.
Jim Simon said, if you saw down there earlier, saying, Jim Simon said, we started making money, we didn't let humans do anything anymore. We relied on the computers. I think you would disagree with that, right? We had a discussion earlier about, you didn't like the whole idea of don't trust your gut. Instead, do it on the data.
No, I actually do like it, and I'll try to explain why. What I don't like is this phrase that we find in the press all the time, which is, you can't trust your gut instinct, you have to be fact-based decisioning. As if our instinctual things were somehow wrong and correct. The things of fear and flight, nurture and caring, these are things that are an instinct. Fact-based decisioning is what we've all done through our careers as we gain knowledge. The problem, and the thing that I think is so critical in the conversation here, is what you have to understand, the breadth of what's coming at you, this flow of information is faster than the single human capacity. And so you have to augment that. You have to find a way to accelerate. And that's essentially what he was saying, is we have to use computers to accelerate, to reduce the bias, because it takes too long as humans to go from knowledge to wisdom, which is the reduction, if you will, of bias.
Could we use another real-time example? Explain to me the example of tamoxifin that you explained earlier.
Yeah, so tamoxifin is a cancer for breast cancer, and it's a great example of a place where big data applies, where if you just looked at the data they had from the trials, you're seeing that it was having 80% effectiveness.
80%.
80%, which is great. That's a great result for a drug. But once they were able to pull all the trial information and add the DNA sequencing, then they were able to understand that it wasn't just 80% of the time, it was 100% of the time for 80% of the patients.
Mm-hmm.
Right? So that's a great example of computational power plus this additional breadth of information you can now process to get to this point where we can specifically say that drug is going to have 100% effectiveness just for you.
The input data there was the patient's DNA?
It was the DNA sequencing, yes, and being able to pull a larger collection of patients.
This is a financial audience. Give us an example of how this could be useful to a bank.
Well, it's very useful in the area of establishing risk and fraud. If you take the example of fraud, credit card fraud, just use that one. With the previous computational power, you might not be able to process all of the transactions to see which ones might exhibit a fraudulent behavior. Today, we can process all of those, model to much more greater accuracy, if you will, and we then can ingest at a speed where we can do every transaction. So just 3 years ago, the leading provider of that was looking at sampling for fraud and using only wasn't taking every transaction into account when looking for fraud to score it. Today, we can do the complete population of the information, much more accurate prediction, so that you don't get a call at 12 o'clock at night when you're in Europe because you actually are there.
Right.
And we're actually able to do that for every credit card transaction.
What about in terms of cross-selling?
A good example of what people are trying to get to is, we've been doing clustering techniques for marketing for a long time, but we want to get to micro-segmentation. So one of the quick marts, or the gas stations where they make the majority of their money from, you go in, you buy a Coke, you buy a snack. They were really struggling for understanding their market basket because they have no loyalty card in that process. But today, they can take every transaction down to a 10-minute interval. Along with the gas price, they can tell exactly what every penny of gas price affects every market basket in every store geographically, so it's unique. So they can now start talking about stocking the stores, pricing directly each item in the store.
If the price of gas moves by a certain number of cents, we should buy fewer Pop-Tarts this week?
It turns out you do. It's amazing. I was completely surprised. I got to see that by stores less than 5 miles apart, we could show the difference in the buying behavior by a penny in gas price.
Can you? I mean, I was joking about the Pop-Tarts. You were serious. Give me an example. I mean, they decided that they weren't going to get as many. They bought less coffee. Seriously?
They bought fewer burritos.
They bought fewer burritos.
Yes. So go price up a penny, less food.
It may sound silly, but it's incredibly important for inventory management for a company and for saving money on the margins, especially in a business like that where the margins, at least
Absolutely.
within the store, are so wafer thin.
Absolutely.
Yeah.
It changes completely how you establish the pricing, how you find the relationship between the gas price as well as what you're going to sell through the store, because that's where your margin's at. And it completely can disrupt how you talk about your supply chain, because a lot of if you just roll back a little while ago, a lot of the optimization was geographically by region, but we've gotten so much more effective in our supply chain distribution. Now you can think about, how do I stock for maximum value at that specific store?
Wow. Do the privacy freaks hate you?
I don't know that they hate me. I'm just of the opinion that we speak about privacy with our wallets, the information we're willing to give up to get back a value. So I'm on the far side of, if they can know more about me so I don't get any spam, so I get the products I want, I get the medical service that I need, then I'm willing to give up that information for that value.
But the critics will say, but at some point, the government can access it, or it can be used for things that aren't so great?
Well, I think this is one of my biggest disappointments. If you look specifically to the U.S., our first piece was on the Patriot Act, where we started telling people, look, we can come into any cloud provider, we can sequester that equipment, and we can look at that data. Now with what we've seen with the NSA and what we're seeing in several things of late, we're doing both the U.S. specifically a disservice on how we can grow businesses to handle and process this data for a global community. And much of that's going to go to other countries because of that.
Interesting. So the trade-off that we have established has been too costly, you think?
It's very costly. I'm having to go and establish hosting centers in many countries around the world because they cannot trust the fact that I can house their data here in the U.S.
Interesting. Well, should I have asked you, or did you expect me to ask you?
You want to help her here?
We only have 40 seconds left, so you can,
40 seconds left.
you can stall and dribble till the
Well, I
final
think
basket.
the takeaway that I would like to encourage you is to make sure that you talk about this computational power is changing, and it is today. So you need to be talking about what the investment is that you're going to make today to leverage this computational power. We've seen some of these algorithms that are coming to fruition in 3 years, some of them 5 years. Your ability to apply analytics to your business is now, and you need to change the way you're acquiring that asset and leveraging it.
right now. All right. Thank you so much for doing this.
Yeah,
I
it's a
appreciate
pleasure.
it. Keith Collins.
Hold it. Thanks, Keith. Michelle. So, question for both of you. Can you actually palpably feel the rate of things increasing?
I can, and so I'll just, we started down this path, so we talked a lot about grid computing. It's for real. So this model of Hadoop is fairly simplistic to what's actually available and what we're able to deliver in the market right now in terms of large-scale grid computing, all in memory, changing models that for one of the largest banks here, looking at the fraud problem, went from 19 hours to under 3 minutes. Now that completely changes the business process. And then I'm telling that bank, look, in 6 months, we're going to have improved so much that you simply have to buy on the premise of what we told you 6 months ago.
And Michelle, as you're reporting this and you're meeting with amazing C-suite executives from around the world, do you sort of feel like the rate at which this churn,
A lot of them, I think, feel overwhelmed
yeah.
because it's coming at them so fast,
Yeah.
and they are terrified that, Jamie Dimon said recently, every time he goes to Silicon Valley, he feels like he's meeting tons of people who just want to eat his lunch and destroy his business.
They do.
Yeah, and they do, and he's right. So, so they're definitely aware.
So in that stat I threw out in the beginning that said that in 10 years, 40% of today's Fortune 500 companies will no longer exist. I mean, is that a conversation that's taking place in the boardroom with the C-suite executives? Are they concerned about survival, or are they just better bury your head?
They're concerned they're not reacting fast enough.
No. Right. Thank you, guys. Keith, Michelle, a pleasure. Thank you.